In the last set of notes, we talked about finding the orbital notation for a particular element. The orbital notation shows, it's just a written representation of where electrons are located around that nucleus in the electron cloud. And these are the answers we obtained for our examples of nitrogen, iron, and platinum. Today, what we're going to look at is something called the quantum number set. For instance, if we look at the very last electron that is drawn into our orbital notation, which is usually the one we're looking for a quantum number set for, we can find this address for that electron, the quantum number set, by looking at both the principal quantum number, the subsidiary quantum number, the magnetic quantum number, and the spin quantum number. These are the designations we talked about in the notes a couple of days ago. When we look at the first quantum number, that one is the easiest one to find. That first quantum number is simply going to be the energy level that that particular electron is in. For our example here, the energy level for our last electron is the second energy level, so our first quantum number is going to be a 2. The second quantum number, the subsidiary quantum number, is going to be simply looking at what sublevel that particular electron is in. In this case, it's in a p sublevel, but we need to designate that with a number. So if you'll look down here, I've written up a little bit of a kind of a chart. You'll want to have this chart somewhere, either on the back of your notes or a separate sheet of paper. And if you'll notice, I wrote the sublevels down, S, P, D, and F, and I showed that those sublevels are given designations of 0, 1, 2, and 3, respectively, for S, P, D, and F sublevels. So if it's an S sublevel, the second quantum number would be a 0. If it's a P sublevel, it would be a 1, etc. So in our example above, we showed that that last electron is in a P sublevel. So from the chart, we see that the quantum number is going to be designated as a 1 for that P sublevel. The next quantum number, the magnetic quantum number, refers to the orbital that that electron is in. And the orbital the electron is in is also given a number. And we're going to go back to our chart. And you can see that underneath the M here, for the magnetic quantum number, I have written orbital blanks to represent the number of orbitals in an S, P, D, and F. Notice that the S has 1, the P has 3, the D has 5, and the F has 7. If you will remember that the middle blank is always a 0, and that the rest of the blanks are numbered in opposite number line order, then you'll rarely have to refer back to this chart, if ever. The middle blank's 0. Normally, the blank to the right in number line order would be positive 1, and is now negative 1, opposite number line order. And on the left, normally in a normal number line, it would be negatives on the left, but in this case, it's positives. Who decided that? I do not know. In fact, AP doesn't really care. However, I do. I want it to be written like this. So, now that we know we're dealing with a P sublevel, and the electron that we are discussing in the above example is in this final blank, I think you can see that that orbital is given a designation -1. So going back up to our example, then our third quantum number is a -1. And finally, for spin, the spin of the electron It's simply, if it's an up arrow, it gets a positive 1/2. If it's a down arrow, it gets a negative 1/2. So that makes it pretty simple. Since this electron we're looking at is an up arrow, then our final quantum number is going to be a positive 1/2. And that's the quantum number set for the last electron in nitrogen. So let's look now at the last electron in iron. Now be careful, this is where people make a mistake. They will often try to circle the last one on the right, but it's not the furthest one to the right, it's the last one you drew in. And the last one we drew in was this down arrow in this first orbital blank. So this is the one we're going to find a quantum number set for. Notice that since the energy level that it is in is the third energy level, that's going to be our first quantum number. It is a D sublevel, so look in the chart that you made and see that a D sublevel is given a designation of 2. Since this electron is in the first orbital of a D sublevel, remember that 0 is the middle blank always, and it's in opposite number line order, so that tells us that this particular electron is in the +2 designated orbital. And finally, since it's a down arrow this time, it's going to be a negative 1/2 for the final quantum number. Notice that the first two quantum numbers have no sign, but the second two quantum numbers must have a sign even if it's positive. So keep that in mind. For the last example, I'd like you to pause this for just a moment and try to do this last electron on your own. Recall that this middle down arrow is the last electron that you drew in for the orbital notation. So pause this really quick and see if you can do the orbital notation on your own real quick. So hopefully you did that, and I hope that you came up with this quantum number set. Keeping in mind that since the number of the energy level is 5, that's our first quantum number. Since once again we have a D sublevel, it's given a designation of 2. Since it's in the middle blank, the middle orbital in a D set, it's going to be given a designation 0. And finally, since it's a down arrow, it's going to have the designation negative 1/2. And that's the quantum number set for the last electron in platinum.